Hello students, welcome to the course Network Theory. In the previous video, we started off with the node analysis for AC networks and we have explained in detail so how to solve a for node voltages for a given network. Okay, so to continue the discussion, we will see another problem in this video. So note down the question. Calculate the power delivered by the source in this circuit shown in figure using node method. Okay, so this is a circuit, so you have four nodes here, so just note down. So this is the source, current source is given 15.7 at an angle 0 degree amps. Then you have two more. So again you remember this in the node analysis in the beginning I mentioned this, right? So it can be given in terms of resistance or conductance. So in this circuit it is given in terms of again conductance. Okay, so that's why no need to take the ratio reciprocal here, straight away you can add those. Okay, so these two more which is present between node 1 and 3. Between 1 and 2 you have z1 ohm, and 2 and 3 z2 ohm. Then between 1 to reference node, so this is the reference node here because it is connected to all the branches. So one more, two more, and it is 1 minus j more. So the calculation also together it is given. So this one it is maybe minus j. So together it is series 1 minus j more. Okay. So note down this question. So what they have asked in this question, power delivered by the source. What is the source here? Current source. Okay. So what is meant by power? So power is equation is V equal to I. Okay. So voltage into current is power. So in this case, current is given 15.7 at an angle 0 degree. But we don't know. So what is this voltage actually? So what is the voltage across this power? Which is nothing but the V1, right? So this is the V1 voltage which is connected to this. So in this manner, plus minus V1 node voltage, right? In case here one more element was there, so then the meaning was different, right? So this is connected like this. One is connected this side and one is connected that side. That means so this node voltage should be multiplied with this I. So that's why we can say this is 1 means it is V1 and accordingly this is V2 and accordingly this is V3. Okay, that means the power is nothing but V1 into I in this case. Okay, so to find out V1 here alone we could not find out V1, so we require the node equations here. So three nodes are there, three node equations are required. From that you have to calculate for V1. Okay, so since we are using Cramer's rule here, so together we could not get all the three answers, right? So whichever is required we can go through. Okay, so for example I want V1 now, so I can find out the delta 1 and delta, only two determinants I can find out, and then if I take the ratio I will get the V1. Okay, so then this V1 I can multiply with the current and I will get the power. So that is what the concept of this problem is about. So now what is your first method? So you have to write the node equations for the three nodes. Okay, so hope you have gone through previously the same way. Whatever we have done in DC case also, it will apply over here. Okay, so now how to write the equation? So first case you see 1, what are and all connected. So self 1 means it is self, so it is 1 plus 2, 1 plus 2 plus j1. Okay, so 3 v1. Then with respect to 2 you have minus j v2. Okay, then with respect to 3 you have 2 minus 2 v3 equal to current is I entering the node here, so 15.7 at an angle 0 degree. So first equation is over. Similarly second equation, so with respect to 1 you have j, so minus j v1. Self you have 2 plus j1 plus j2 v2. Then with respect to 3 you have j2, so minus j2 v3 equal to, so no current entering this node, so it is 0. Clear? So similarly 3, so you have with respect to 1 you have 2, so minus 2 v1. With respect to 2 you have j2, so minus j2 v2. Then with respect to 3 all connected, right? So it is 2 plus j2 plus 1 minus j into v3. Okay, equal to, again here no current, so it is 0. So you got the three equations, simplify that and find out, write it in matrix form and then find the determinant delta and then find the determinant delta 1 by placing the right side terms. So you'll get delta 1 by delta. So that is the V1. Okay. So once you got V1, so you multiply with I. So you'll get the power. So this is the idea of the problem. Okay. So just follow the node equations. Whatever I said, I have written here. So KCL applied at each of the nodes. So first, okay, so it is simplified, right? So straight away I have written 2 plus 1 is 3 and plus j. 3 plus j V1 minus j V2 minus 2 V3, 15.7 at an angle 0 degree. Okay. So this you know already. Okay, 15.7 at an angle 0 degree. If you convert, you will get 15.7 itself. Okay, in terms of polar form. Next you have minus jv1 2 plus j3 v2 and minus j2 v3 is equal to 0. And at third you have minus 2v1 minus 2j v2 plus. It is directly written here. So there were 2 plus 1 was there in real part. So 3 I have made, and 2j minus j was there, right? So plus j. So 3 plus j v3 straight away written here, and it is equal to 0. So you got the three equations. So write this in matrix form. So this is the matrix form. Okay. So 3 plus j minus 2 minus j 3 plus 3j minus 2j. All the coordinates or coefficients of v1, v2, v3 are written here. And right side you have 15.7, 0 and 0. So first thing, so first calculation is your determinant now. So the same matrix you have to write it in this form, and this is the determinant. So how to compute this determinant now? So first you have to consider this 3 plus j. This you have to multiply with this determinant. Okay, so inside determinant 2 plus 3j minus 2j minus 2j 3 plus j. Okay, then you have minus of this term minus j. So excluding this row and column, whichever is left out. So this row and this row you should consider for second one. Then plus again, plus 2 into, sorry, here already minus 2 is there. So plus means minus, plus minus minus 2 into, so which, so this row and this column left out. That means this column minus j minus 2 and this column 2 plus 3j minus 2j will be computed. So that is the step I am going to show next. Okay, so finding the delta determinant. So it is a detailed step, so very careful here while computing. Okay, you can use the calculator help also. So 3 plus j, so how much possible you do it manually. Okay, it is better. So 2 plus 3j, 3 plus j minus 2j square. So just observe that determinant. Then plus j minus j 3 plus j minus 2 into 2j. Then minus plus minus, I told you no, 2 minus j minus 2j plus 2 into 2 plus 3j. So this is how I shown you. So now further steps are simplification. So just doing the multiplication and grouping the terms. So 3 plus j inside brackets we will simplify first. 2 into 3 is 6. Okay, 2 into j is 2j. 3 into 3 9j. 3j into j. Okay, so what will come? Minus 3. I told you j square is minus 1. Okay, so j square is equal to minus 1. So that's why 3 into 3, 3 into 1 is 3 and minus 1, so minus 3. Then you have minus 2j whole square. So minus 2j whole square means what? It is 2j into 2j. 2 into 2 4, and j into j is j square minus 1, so it is minus 4. So minus 4 outside bracket, minus is there, so it's why plus 4. Clear? Then plus j into bracket terms we will solve first. Minus 3j plus, so minus j square will come. So j square is minus 1, so minus of minus 1 is plus 1. Minus 2 into 2j 4j. Okay, then minus 2 here, minus j minus 2j, so it is plus 2j square. So j square is minus 1, that's why minus 2. Then 2 into 2 4, 2 into 3 6j. Okay, so now add this inside terms. Okay, so you have 6 plus 4 10, 10 minus 3 7. Okay, and then 2j plus 9j, so 7 plus 11j. Okay, similarly j into here plus 1 and minus 3 minus 4 minus 7j, so 1 minus 7j. Then minus 2 here, minus 2 plus 4 plus 2 and plus 6j. Clear? Now you multiply with the outside terms. So 3 into 7 21, 3 into 11j 33j, j into 7 7j, j into 11j, it is minus 11. Clear? Then j into 1 is j, so j into minus 7j, so it is 7 into minus 1, so plus 7 you will get. Then minus 2 into 2 minus 4, minus 2 into minus 6j minus 12j. So now you combine all the real parts and imaginary parts. So 21 minus 11 10, 10 plus 7 17, 17 minus 4 13, so that's why 13. So then 33 plus 7 40, 40 plus 1 41, 41 minus 12 29. So 13 plus 29j. So you keep it as it is in the polar form. At the final answer we will convert it into rectangular form. Okay, so this is how we simplify in AC networks. Okay, so that's why it is quite difficult to, but it is all numerical, only the first step is important. Then we'll find the determinant 1 delta 1, because we need to find the v1 here. Okay, so that's why we'll not go through all the things, only delta 1. So just replace the first column with right side column 15.700, and this is as it is. So again you write same way, 15.7 into this determinant 2.3j into 3 plus j minus 2j whole square plus, so minus of minus here plus j into, so both terms are 0 here, so cross multiplying 0 with 3j, 0 with minus 2j will give 0, that's why just 0 I have written. Then plus minus 2, so plus minus minus 2 it is. Again here two terms are 0, if you multiply with these two terms again you will get 0. Okay, so this complete two terms will vanish out in this example. Okay, so only this part you have to simplify. First simplify the inside brackets, again same as previous. Okay, 2 into 3 6 plus 2j plus 9j you will get minus 3 plus 4. It is same as the determinant one, first one. Okay, only outside term is different. So now 15.7 you need to multiply with 7 plus 11j. Okay, so 15.7 is 109.9. You can use the calculator, and 15.7 into 11 is 172.7j. Okay, so hope this is understood. So now we will take the ratio of this delta 1 by delta, so you'll get the v1. Okay, so v1 is equal to delta 1 by delta, so just write down the delta 1 and delta. Now use the calculator here. So this I have shown you in the mesh analysis networks only. Use the network calculator in complex mode. Okay, and then write a plus bi form. Okay, so eng button if you press you will get the I. Okay, so I you write in the right side, 109.9 plus 172i, use the brackets. Okay, in the calculator, divided by, again use the bracket, 13 plus 29j. Okay, so when you use that, so you will get the answer 6.373, and if you click shift equal to you will get the j term. Okay, minus 0.93i it will come, I means j here. Okay, so this is the answer. So if you convert this into rectangular form also, so you may get, okay, you can do that, just shift x if you click. Okay, okay, so shift plus symbol, you have the r at an angle theta, so it may come 6.44 at an angle something minus 83 degree. Okay, so not necessary this value. Okay, so this is the magnitude at an angle. Okay, so now we need to find the power. Okay, power delivered by the source, that's what asked. No, if you miss this step you'll lose the marks. Okay, this is the important thing they have asked. Okay, source I is equal to real of v1 into I, that means real part of v1, or else you can take the magnitude of this value. Okay, 6.44 you can take, or 6.33, not much difference, into current 15.7. Okay, at an angle 0 degree means 15.7. So when you compute that you will get 100.05 watts, 100.05 watts. Okay, so this is the problem. Okay, so hope you have understood. So what is the difference here? We have considered in terms of mho in this case. Okay, so that's why, so straight away equation, so no simplification you had in the equation part. Compared to yesterday's problem, it is very simple. Okay, so uh, hope you have understood this problem. Any doubts you can ask. Okay, so you go through once again the video. So always when you are learning something new, first time you will not understand, it requires some 2 to 3 times to see. Okay, so regular classes this opportunity was not there. Okay, and the clouds were cleared there, very good, but This is the situation we need to adopt now. So go through. Okay, and in the next video we'll solve one more problem and we'll complete the we'll summarize the node analysis and mesh analysis, and with that we'll end the module also. Okay, so after Diwali, so we'll be having the second module. After that I may go fast. Okay, so this is the first module, the basics node analysis and mesh analysis, very very basic. So that's why I have taken a long time and much problems. Okay, thank you, we'll see in the next video.